everyone, and welcome to our lesson on stretching, shrinking, and reflecting the graph of f of x equals x squared, also known as parabolas. You need to know what to be on the lookout for to know if these changes have occurred. So what you're going to be looking out for is if you see a number in front of our x squared or our x squared expression power that has an absolute value that is greater than 1, that is going to cause a stretch, which means pulling it up and stretching it more towards the y-axis. If you see a number sitting there in front that has an absolute value that's less than 1, like a fraction, that is going to cause a shrink, going to kind of compress the graph down and make it wider. So here's some examples of what you'll see. Stretches, you will see those integers or positive or negative integers sitting out there in front, like 5 or -4. And then for the shrinks, you'll be on the lookout for the fractions, like 1/3 or a negative fraction even. It doesn't matter if it's positive or negative. If it's a whole number, the absolute value is greater than 1, it'll still cause a stretch, and if it's a fraction, it'll still cause a shrink. The negatives come into play for the reflections. If you do see a negative sign there, what that's going to do is flip the parabola down over the x-axis. So it'll be opening the other way. Alright, so let's take a look at the graph of these. The regular parent graph parabola f of x equals x squared is going to look something like this. It's going to be opening up, going to occur on the origin, go through the point 2,4, and you could test some other points to find the exact true picture of the parent graph. But I wanted to show you what a stretch and shrink looks like. So a stretch is going to be pulling it towards the y-axis. Let's take a look at that. It should be skinnier than the original graph, something like that, and it'll sort of be pulling up higher and higher towards the y-axis. Whereas a shrink is going to kind of look like we've pressed down on the top and compressed it a little bit. It'll get wider and wider. And we don't know how thin or how wide until we test some points to get a true accurate picture. But that's basically what you'll see. Alright, so I talked a little bit about reflections, and here's a recap of that. Just remember, if you are looking in the front of the operation and you do see a negative sign, that is going to reflect the picture down over the x-axis, wherever your picture may be. It may not be on the origin, maybe somewhere else in the grid, but it is going to flip it downward. Alright, so knowing all of these things now, and mostly right now we're dealing with f of x equals x squared on the origin, how will we write the equation if we see a graph? Well, we will look for a point, look for any point that it's going through, and then when we have a point, we have an x and a y coordinate, so we can substitute the x and the y values into the y equals x squared function and solve for that number that should be sitting in front. If we want to see how much it's been stretched or compressed, then we're going to look for that coefficient. So let's take a look at an example. Let's say that we have a parabola here, and it's moving through a few points on the graph, but one that we can see is the point 2,8. All right, if I notice that my picture is going through the point 2,8, how much has this parabola been had a stretch or a shrink? We don't know. So let's substitute in that 2,8 xy value into this equation. Alright, so 2,8 means the 2 is my x, 8 is my y. So I'm going to put 8 in front, leave the a blank because that's what we're trying to solve for. We don't know what that is yet. And then put our 2 for x. See what we get. We need to solve for a, so we need to get it by itself. So 8 equals a times 4. When we square our 2, dividing by 4. To get rid of that and get a all by itself will give me an a value of 2. So now I know that my parabola has had a stretch occur because that 2 has an absolute value that is bigger than 1. So my equation is actually, since I see it sitting on the origin, y equals 2x squared. I don't see any other translations that have occurred on this graph, so this is my final written equation. And this concludes our lesson on stretching, shrinking, and reflecting the graph of f of x equals x squared.